the probability and statistics. This first one is looking at soap powder, considers the brand Gleam, and the weight of a packet of Gleam has 750 grams with a standard deviation of 20. So if for the packet, I'm going to call the packet, what is mu equal to? 750, right? Grams. What is the variance of this thing? Thank you. It's 20 squared, or 400. Good with that? No? Standard deviation is the square root of the variance. So if you have a standard deviation of 20, you square it, you get the variance. Variance is the standard deviation. You like that data. Okay, and then they have a tiny packet, the weight of packaging. So I would call this an individual packet. The mu is, yeah.
So you would just add 40 to 750.
Yep. So this is going to be 40 grams. And here the standard deviation is going to be 5 squared, or 25. Find the probability that a randomly chosen packet of Gleam has a total weight. Find the probability that the total weight is greater than 780. Yeah, isn't one of them just the container? Okay. So then what we're looking for here is the combined. We want to know what, well, I would start with, before we do anything further, let's talk about a normal distribution. Normal CDF. That's from the low to the high, the expected value, comma, the standard deviation, not the variance. Okay? That's what you put into your calculator. So what we need to know is what is the expected value of the two of them, x plus y. Well, the expected value of the two of them is just the sum, 750 plus 40, which is going to be 790. And that's what's going to go here, 790. The variance of x plus y is going to be the variance of the first one, which was 400, plus the variance of the second one, which is 25, which is 425. So what will I put here for my calculator? Square root of 425. That's what your calculator is programmed to do.
So why not just use 25 and then do the variance? Or sorry, why not just use 45? Yeah, why not use 25 and then do the variance?
You mean do 5?
Wait, that's right.
All right. So we're starting at, the weight is going to be greater than 780. So we're going to start at 780. And what's our high? I would just make up something big like, 100,000 is fine. Anything over 5 standard deviations, whatever that standard deviation is going to be fine. You'd use your calculator. Yeah. Could you take your calculator and do this right now? And everybody got 0.686. That's a 68% chance, 69% chance that that will happen. The weight is greater than that. So that's part I. Let's do the next one. Now, the probability that the total weight of the contents, find the probability the total weight of the contents of 5 chosen packets exceeds 3,800. So all that you're doing with that is, and I'm running out of room here, so I'm just going to kind of continue this down here, is you need to find the expected value of 5 of those, of the x's, and the variance of 5 of those x's. Okay? And what they did for that is they got 5 times, I think it was expected value of that first one. Or is that the combo of those two? No, just the content, 750. Okay? And then for the variance, I thought you'd have to square that, but they didn't. They just took 5 times 400. So then you do the same thing. Normal CDF of exceeding 3,800. So we're finding the probability that the weight combined exceeds 3,800. So this is going to start at 3,800, go to 100,000 again. Now our mean is 5 times 750, which is 3,750. And then the variance is 5 times 4,000, which is 20,000. That's the variance. So what do we have to do to that number, putting into our calculator? Subtle. Too many zeros, right? Huh? Oh, yeah. Mm-hmm. 5 times 400. Yep. And then go ahead and crank that out. Tell me what probability you get for that. Did you get 0.132? Good. And now we're ready for the last one. Sammy now considers the brand Bright. The weight of the contents of the randomly chosen packet of Bright follows a normal distribution with a mean of 650. So this is a new one. So let's call this new one B. And the expected value of B, or mu of B, is going to be 650. And then we're going to have a standard deviation. So the variance of B is going to be 16 squared. Let's find the probability that the contents of 6 of these, so we're going to take 6 of these, and we're going to compare them with the 5 of the gleam. 5 of these, which was expectation of gleam, which we had, I think it was 750. And then the variance of gleam, it's a G, is equal to 20, right? Find the probability that the contents of 6 of these weigh more than 5 of those. That's interesting. So find the probability that the contents of 6 of them weigh more than the contents of 5. So what I would do is I would say 6 times the expected value of the Bright minus 5 times the expected value of the gleam has to be greater than what? 0, yep. Yeah. So they're just going, what we did is they just found what the book did or I did or whoever. H is going to be this, and we want to set up our normal distribution, normal CDF. We're going to start at 0 and go to 100,000 again because we want it to be greater than 0, right? We want to show these are greater than 0. And then we just need these two things again. So let's find the expected value of this H. So this is going to be 6 times 750 minus 5 times 650. I'll need a calculation there. And then the variance of H is going to be 6 times 16 squared minus 5 times 20 squared, right? Huh? Yeah, I think so. These should be in reverse. So how is this? 650 and 750? Is that all right? And then this is going to be 6 times whatever 16 squared is. What is that? Anybody know that off the top of your 256? Yeah. 400. So what is this 6 times 650 minus 5 times 750? What's that? And what's this one? Is this 150? And 35, 36? That sound right? So we caught that one quick here. When you're looking at the expected values, you want them to be the difference greater than 0. But the variances are going to accumulate, so they're going to add. They accumulate. So then when we write these down, 0, we want it to be greater than 0, 0 to infinity or 100,000. I think you put 150 here, but tell me what I put there. It's not 3536. What is it? Square root of that. And tell me what you got for the probability that the weight exceeds 3,800. Isn't it? No. The weight's greater than 0. The difference is greater than 0. The difference is greater than 0. What did you get? Did you get 0.994? I win. There you go.